Hey everyone, Krishna this side, and I welcome you all to this channel. So let's solve this LeetCode question 3495, minimum operations to make array elements 0. Okay, let us read the problem statement quickly. You are given a 2D array queries where queries of I is in a form of L to R. Each queries of I defines an array of integer nums consisting of elements ranging from L to R, and both are inclusive. Okay, in one operation you can select two integers A and B from the array. Okay, whatever the nums array that we have, and then we have to replace them with floor of a divided by 4 and floor of a divided by 4. Your task is to determine minimum number of operations required to reduce all the elements of the array to 0 for each query. Return sum of results of all the queries. Okay. So the goal is whatever the queries range elements that we have, we just have to pick any two elements and we have to divide them with 4, and we have to make sure that all the elements that are available in this particular nums array, they becomes 0. And minimum operation is something what we have to consider, and whatever the result that we are getting it, we have to just sum them up and we have to return the results. Okay, so if we look in the first example, right, so here the query 0 is having range from 1 to 2, so only two elements that we have here. So nums of 0 and nums of 1, only those two elements we can pick, and we can divide them with 4, so the answer becomes 0 0 immediately at single operation itself. Okay, so here it require one operation to make array elements 0. Okay, in next this is the second query that we have, query 1. So here the range is like 2 to 4, so nums becomes like 2 3 4. In first operation what we can do is we can pick 0th element and second element that is there in this particular nums array, and when we divide them with 4, so 2 divided by 4 is going to be 0, 4 divided by 4 is going to be 1. Okay. Next we can pick this 3 and 1 in second operation, and again when we divide them with 4, the entire array becomes 0. Okay, here it required two operations. So in total, previously it required one operation, here it required two operations, so total three operations we require to make elements becomes 0. Okay, I guess the question is pretty much clear. So if we look into the constraints as well, this queries dot length go all the way to 10 to the power of 5, and this L and R also it has values up to 10 to the power of 9. So the constraints are really required while solving this kind of questions. So now let's see how we can solve this one. Let me connect the screen and I'll explain you brute force solution, and then we'll discuss about the optimal solution, and I'll write down the code as well at the end. Okay. Okay, let us suppose 2 to 4, this is the query that we have. We can have multiple queries, but for now we can consider only single query, and whatever the answer that we are getting it, the only option is we have to sum them up, right? So we will perform similar kind of operation on all the queries. Okay, let us suppose 2 to 4 is the range, so the array elements becomes 2 3 4. Okay, now let us say that we'll try to just perform the same operations what they are trying to say. We'll pick two elements and we'll divide them with 4, and we'll put them into the array again back, and we'll keep on checking like in how many operations the array events becomes 0. If we start from starting onwards, right, like let us suppose if we pick this is A, this is B, and when we divide them, the array becomes like 0 0 4. So this is basically one operation. In next operation we don't have any choice. The moment any elements become 0, we have to go into the next element. At any point in time, if this is also 0, we have to go, but we have to make sure that the array size is also uh, proper. Okay, so here I have to pick these two elements at this point in time, so the elements becomes like this one, and it was second operation, and lastly 0 0 0 by picking these two elements. So here it required three options, but is it optimal solution? No, right? So if we try to pick this one and this one, okay, 2 and 4, so here is our left pointer, here is our right pointer, and by picking them, so in first operation it is like 1 3, sorry, it is 0 3 1. Okay, now the moment elements become 0, we will shift our pointers. Okay, left pointer is basically right over here, right pointer is still at that point, because this is not 0 8. So it was first operation, and second operation what we have to do is all this left and right pointers we will pick. Now in this particular one, all the elements become 0, so left pointer points, right pointer points here, left pointer points here. The moment left and right pointer shift their positions, we are done. So here it required two operations in total. So the idea is like we will simply pick a point here, left pointer, last at last index the right pointer is basically pointing, and we will keep on performing the operations, and the moment left and right pointers goes crosses each other, we will return the answers. Okay, so this is one of the way. Okay, but considering the constraints that we have, when we try to solve this one, definitely it is going to give us TLE at any point in time. Okay, so there should be some better approaches, right? So let me clean this stuff, and I'll discuss about optimal solution, and then I'll write down the code as well. Okay. Okay. Before going to this particular example, let us suppose we have these two elements. Okay. Let us suppose 1 to 2 is the range. So here the array elements are 1 and 2. Okay, now if we able to figure out in how many operations any particular element that is there, it requires how many operations to becomes 0, right? So if we able to figure out that, can we try to solve it in different ways? Okay, that is the question. Okay, here if we divide it with 4, in one operation, single operation itself, this element going to be 0. Okay, here also for this two, in single operation, this is going to be 0. So it requires one operation. So, okay, each of these elements require one operation. Okay, now can we say that if we add these operations, okay, it require in total two operations. Okay, so the idea is whatever the elements that we are picking, only two elements that we are picking at each time. So here it required two operations in total. So these two operations divided by 2, if we do, the answer that we are getting is going to be the correct answer that we say. Can we say that? Right. So see, here it required one operation, this also required one operation. Okay, so obviously this for first operation, this is going to be 0, this is going to be 0. So in total, like these two operations we required, so two elements is something what we have picked. Okay, so obviously we have to pick two elements at each point in time. So total operations divided by 2, if we do, whatever the answer that we are getting is going to be same that what we are getting it by reducing them each time by dividing them with 4, right? That is going to be same, right? Like let us discuss about this another example. Let us suppose 4 to 6 is something what we have range. So here it is like 4, 5, 6. So for making this 4 to becomes 0, it requires two operations, right? Like in first operation, it is going to be 1, and second operation, it is going to be 0. So it requires two operations. For 5 also, it is also required two operations. In first operation, it is going to be 1, and second operation is 0. 6 also requires two operations. So in total, if we say that when we add them, so in total 6 operations we have. So 6 divided by 2, if we do, 3 is the answer that we are getting, and this is the answer that we are looking at, right? So see, for 4 and 5, let us suppose we divided them. So it is going to be in first operation, they becomes 1, 1, and 6 is there. Okay, this was one operation. So it is like we just consider these two elements, 4 and 5. So each required one operation. So 2 divided by 1 is going to be one operation. Okay, the same operation is something what I'm trying to do. So in total, how many operations that we have? Okay, when we add them and when we divide it with 2, is it really correct that whatever the answer that we are getting is going to be the same exact answer that we are trying to look out for? Okay, it is going to be same, right? So just try to think properly, then you will get this idea, like what I'm trying to say here. So let us suppose we have these next elements are like 3, 4, and 5. So 3 basically requires one operation, 4 requires two operations, 5 requires two operations to become 0. So when we add them up, it is like 5. So obviously, whenever we see odd number, if we see odd number, there could be chance that one particular operation left at the end. Okay, one operation is going to be there, and we have to consider that one operation with any other number that is already becomes 0, and this is going to be one extra option, that is something what we can say that. So at any point in time, if we get odd numbers, we just have to simply add 1 and divide it with 2, so we will get correct answer. The three answer is something what we are looking at. So let us try to solve this one as well. Like 3, 4, 5 we have. When in first operation, let us suppose I picked this 3, 3, 4, 5 something what we have. Let us suppose I picked 3. Let me just take a pause. Okay, I'm back. So this 5 again, when we divide it with 4, right? Let us suppose these two operations we are picking. So this becomes 0, this becomes 1, and this is going to be 4. Okay, this is going to be 0. So we can say that, right? Like here it is basically 1 operation. Here from here also we pick one operation. So in total 2 divided by 2 is going to be 1. So in total one operation we require. Okay, so that is something what we can say. And now these two pairs is something what we have to pick. Again, this is going to be 1, this is going to be 0, and lastly this is like second operation, and lastly again this is going to be 0, 0. So it is like 3 operations in total we require. That is the same answer that we are looking at. Exactly. Last one example I'll say, let's suppose we have 2, 3, and 4. Here it requires one operation to become 0. It requires one operations to become 0. This requires two operations to become 0. Okay. Now see, in total these are like 2 plus 2 is 4. In total 4 operations we have. So when we divide, 2 is the answer that we are getting, and this is the answer that we can say that. Okay. See how we can say that. See, this first one that is there, right? Like we reduced it 0. Like this one operation we consume. This also we consumed. So in total one operation is required. So that is like from here we picked one operation. From here we picked one operation. So in total like two operations we have. So 2 divided by 2 is going to be 1. So one operation is something what we consumed, and at one time we are just trying to reduce two values. Okay, that is the goal. So that is why we are dividing with them two. Now lastly, these two elements that we there we have. So here from also this is also one operation we consume, from here one operation we consume. So in total two operations we consume, two values that we have we consumed, and two is something what we have to divide, because that is something what we are trying to do is right. So in total one is the answer that we are getting. So that is the whole idea behind it, like 1 plus 2, in total four entire operations we have. So when we divide with them with 2, 2 is the answer we are getting it. At any point in time, if we are getting odd sum, so we simply add 1 to it and then we will divide, so that correct answer is something what we will get it. Because at the end, if there is odd operations we have, so one operation will be left at the end, and to consume that one we have to just pair it with 0, and the answer is going to be, this is like extra operation that we will going to have. Okay, that is the whole idea. So yes, we are clear that if we able to figure out, let us suppose again we have this range to let us suppose 16 is the range that we have. Okay, so array elements become like 2 3 4 5 all the way to 16. Okay, these are the array elements that we have. So 2 basically require one operation, 3 require one operation, 4 require two operations. It goes all the way till 15. We see that it requires two operations. Now only for the 16 it requires three operations. Okay, it requires three operations. Now when we add all of these values, okay, when we add all of these values, and we will see that if it is odd, we will plus 1 into it and we will divide it with 2. Whatever the answer that we are getting it, that is the answer that we are actually looking at for. Okay, so the only idea is we just have to figure out how we can get in how many operations these particular numbers are basically uh, getting converted into 0. That is the whole idea now. Okay, that is something what we will see it now. Okay. Okay, so let us carefully observe these values, right? Let us suppose these values are starting from 1, it goes all the way to, let us suppose, 64. This is the range that we have given. So it is, if we carefully observe here, 1, 2, 3, these elements basically taking one operations to become 0. Now 4 onwards, if we consider 5, 6, all the way to 15, okay, these all elements are basically taking two operations. Now let us suppose like 15 is something what we have. When we divide it with 4, answer becomes 3. 3 divided by 4 is going to be 1. So in total, like sorry, it is going to be 0. In total, it is taking two operations. Even for 4, 4 divided by 4 is going to be 1, 1 divided by 4 is going to be again 0. Okay, so 4 also taking two operations. From 4 to 16 onwards, 15 till 15, it is basically taking two operations. Now from 16 to 63, okay, in this particular one, it is basically taking three operations. Okay, let us suppose like 63 is something what we have. When we divide it with 4, the answer is going to be 15. 15 divided by 4 is going to be 3. 3 divided by 4 is going to be 0. So it is taking three options. Even for 16, it is going to be the same. Okay, so we notice that here these ranges that we are seeing. Okay, next from 64 onwards to all the way to 55. Okay, this basically takes four operations. We notice that carefully when we observe them, they are basically multiple of 4s. Okay, from here to here, okay, it is actually multiple of 4, right? So like all these elements from starting from 1 uh, and 4, the 4 is basically inclusive. So or exclusive. Okay, sorry, not inclusive, it is exclusive. These all the values that are available in this particular range basically taking one operations. Now from 4 onwards to 16, okay, 16 is exclusive. So here they are taking two operations. From 16 onwards to 64, okay, 64 is exclusive. They are taking three operations. From 64 onwards to 256, okay, 60, this is going to be exclusive. This is basically taking four options. So on, this is how the values are basically getting represented right over here. Okay, so let us suppose any range that we are getting. Okay, any range that we have from 2 to, let us suppose, 16 is something the range that we got it. So 2 basically lies in this particular range. Okay, so what we can do is we will just try to figure out like how many elements, okay, from 2 to how many elements that are there which are basically less than this 4. Okay, which are basically less than this 4 and greater than this 1, greater than or equals to this 1. Okay, if we able to figure out that, okay, we will get to know that all the elements that are available, because this range is continuous form. Okay, range is actually continuous in form. So here 2 basically lies in this particular range. Okay, so from 2 to 3, okay, these two elements basically lies in this particular range. Okay, so if we able to figure out like how many elements that are there which are basically lies in this particular range, so here it is like two elements that are there. So two elements basically taking one operation. Okay, that is something what we figured out. Now next is like from 4 onwards to till 16, which is exclusive here. 16 is exclusive here. So all the elements here, the range is 16, So we can say that 4 to 16, 4 to 15 elements are also available in this particular range. 4 to 15 also available in this particular range, which are basically taking two operations. So here it is like 2 into 2, sorry, 2, it is like from 15 to 4 plus 1. In total, like here we have how many elements that we have here? 15 minus 4 plus 1 is going to be, obviously it is 12. Okay, so 12 elements are there, okay, in this particular range 2 to 16. Okay, 12 elements that are there in this particular range who are having two operations, who require two operations to become 0. Okay, so what we can do is 12 into 2 is something what we will add it right over here. Now next is like 16 is also there, okay, because 16 is also here. So 16 basically falls in this particular range, so only one element is there which is basically lying in this particular range. So 3 into 1, okay, in total we are getting the answer. But this particular elements and this range, how we can communicate them, that is the question, and that is something what we have to figure out right over here. Okay, we can easily get these answers by checking that which particular elements, how many elements that are there in this particular, any particular ranges lying in this particular ranges, and we can get that value, index values, and we can multiply them simply. But to know that how these elements are lying in this particular range, how we can figure out, that is something what I'll explain you further. Okay. Okay, now the idea is we just want to store these ranges, right? So how we can store these ranges? We can probably use array here. Okay, so how array can be used right over here? So let us suppose at 0th index, array of 0, we will store 1. Array of 1, here we will store 4. So whatever the value that we are getting here, 4, and next one is going to be 16. Array of 2 is going to be 16. Array of 3 is going to be here it is going to be 64. Whatever the previous value that we have, 16, 16 into 4 is something what we are doing it. Now 64 into 4 is something what we are doing it, so it is going to be 256. So array of 3. So this way we will keep on collecting the values, but how long we have to collect these values, right? Like we need to know like what is the range. So L and R's range is basically here. If we look into these constraints, the range is basically defined as it goes all the way to 10 to the power of 9. So 10 to the power of 9, if we convert them into 2's power, okay, so probably it is approximately equals to 2 to the power of 29 point something like that. That is going to be 2 to the power of 30. Okay, so this 10 to the power of 9 is the range. This L and R's range is something what we have. So it goes all the way to the power of 30. So this, if we try to convert them, because we are trying to divide the numbers with 4, so it is going to be 2 to the power of 15. So that is the last operations that we require. So okay, any number, big number that is there, let us suppose 10 to the power of 9 is the value that we have. If I want to convert it into 0 by dividing it with 4, so we require 15 operations at max. Okay, 15 operations is something what we require. Okay, so it goes with all the way to 15, and the value is going to be whatever 10 to the power of 9 something like that. The range is something what it basically defines right over here, 10 to the power of 9 something like that. Okay, so it goes beyond this 10 to the power of 9 as well. But yes, that is how values we somehow we can store them. Okay, we will pre-compute these values. Okay, now the idea is, see, in between this 1 and 4, in between this 1 and 4, can we see that any element that is there, it is lying? Okay, 4 is actually exclusive. We already see that here 1 to 4, 4 is actually exclusive. So we can probably do that, this A1 and A0. In between them, if any element is there, if any element is actually available in this particular range, okay, so those element is something what we will try to pull out. Okay, how many elements that are available in this particular range between A1 and A0. Okay, so A1 is basically 4, 4 minus 1, because 4 is actually exclusive. Okay, that is something what I already said that. So 1, 2, 3, all these elements that are there, they basically require one operation. For from 4 onwards to 15, they require two operations. Sorry, one operations. Okay, so yes, so idea is like we will see that from 1 to probably like from A1 to A0, how many elements that are there which are basically appearing in this particular range. So the answer here, the range is from 4 to 17. So there are none of the elements that are basically lying in this particular range. Okay, so here this is basically our lower bound. The 4 value that we see is basically lower bound. Okay, lower bound, and this 17 is basically our upper bound. Okay, we can at max go till 17. Okay, from considering them by looking into these arrays, whatever the array elements that we have, and the lower value we can see is 4. So from 4 onwards only we have to calculate their values. Okay, I guess this idea is pretty much clear. So what we can do is this whatever this A0 that we have, we are basically looking in this 1 and 4, how many elements that are there in this particular one, right? So this is our lower bound. So obviously 1 to 3 none of the elements that are available in this particular range. So what we can do is logically, if we carefully observe here, from between a0 and this lower bound value, that is 4, whatever the maximum value we are getting it, that is something what we will consider first. Okay, and that, let us suppose we will assign it with the L, and from a1, okay, that is this particular 4, and this 17 is something what we have upper bound. Between them, the minimum value is something what we will pick. Okay, minimum value is something what we will pick. So here it is 4 and 17, so minimum value is 4, and between this a0 and 4, so whatever this value that we are getting it. Okay, so this is basically the lower bound is something what we are considering, right? So 4 minus 1, 3. Between 1 to 3, how many elements that are there? So 4 minus 3 is something what I have to do. So here it is going to be minus 1. 4 minus 1, so it is going to be 3. The minimum value is basically 3, that is going to be R. And here between this a0, that is 1 and 4, the maximum value is 4. Okay, so it is clear that this L is actually greater than this R at this point in time. L is actually greater than this R. Okay, so we can say that these elements in this 1 to 3, there are no elements that are there basically in this particular range. Okay, because we are starting from 4, and there are none of the elements that are there between a0 to a1. Okay, that is the conclusion we can draw here. So let me try to write down the code, simple snippet of the code, and that will I'll keep on explaining you guys. With that, you will get clarity about it. Okay. Okay, simple code snippet I have added right over here to get some more clarity about the operations that we are trying to perform right over here. This is something we already pre-computed the array. It goes all the way 10 to the power of 9, whatever the values that we are getting. So this range is basically, it will give us the clarity like from 1 to 4, that is like 1 to 3, how many elements that are there in this particular range. Okay, that is something what we are trying to figure out, so that this way we can actually perform that operation. Okay, now from 4 to 16, how many elements that are there? From 16 to 64, how many elements that are there? So that is something what we can easily figure out with this one. Okay, so we'll iterate from the first index, and we will check that whatever this 4 value that we have, does it basically lies in this range as well. Okay, because the upper bound we have is 17. So obviously we have to make sure that whatever the lower bound that we are calculating, we have to consider the previous index. Okay, between the previous index and the first index, are there any elements that are there in this particular range? That is the whole idea. That is something what we are trying to figure out right over here. So what we can do is, our lower range that we are going to have is going to be the max between this 4 and the array of I minus 1. Okay, because obviously if 4 is actually greater than this one, 4 is actually greater than this one, obviously we don't want to pick this one, right? So whatever this value 4 maximum value that we have, that is something what we have to consider. But going ahead, if the element is lying in this particular range, let us suppose 16 is something what it is actually lying in this range, so the lower bound is going to be 16 and upper bound is going to be 64, or minimum between this 17 and 64. Okay, so for that, like, upper bound is going to be upper bound, whatever the upper bound value that we have, and array of I minus 1, because 64 is something what we are considering. 64 minus 1 is the range that we have, 63 to 16. Okay, 16 to 63, all these elements basically take 3 operations. Okay, so minus 1 is something what I'm doing right over here. So our lower bound is going to be max between this 4 and array of I minus 1 1. So initially the values are like, lower bounds is basically 4, and the upper bound is going to be maximum between this minimum between this 17 and array of I, that is 4 minus 1, it is going to be 3. Array of I minus 1, it is going to be 3. So lower bound is basically 4, the upper bound is basically 3. So here obviously, if lower bound and upper bound, if they are not uh, proper in sequence, okay, lower bound if it is actually greater than this upper bound, obviously that is not the valid range. We can easily say that, because our range is basically starting from 4, and the upper bound is basically 3. That means like, whatever the elements that are there below this 4, those elements we are not considering in this particular range. That is the whole idea. It basically says we are not simply considering them. Now going ahead, I basically, when it get incremented, I is basically equals to 2. Now between these 4 and 16, how many elements that are there? That is something what we will try to figure out that are there in this particular range. So here again we will check that whatever the maximum value between this lower bound that we have currently and the array of I minus 1. Okay, it is 4. Array of I minus 1, it is 4, right? So maximum value that we are getting is obviously going to be 4. Again here the lower bound is 4. That is something what we were able to figure out. Now the upper bound is 16 minus 1, that is 15. 16 minus 1 is going to be 15. Between 15 and whatever the value that we have, between them minimum value something what we have to get it. Okay, I hope you get this idea like what I am trying to do right over here. So this way we'll get to know that like from 4 to 15 how many elements that are there which are basically taking two operations. Okay, that is something what we can easily figure out right over here. So here it is going to be, again I missed to multiply here with the current index that we have. Okay, that is fine, I'll explain you because we never enter into that particular part. But see, here now the lower bound is 4, the upper bound is going to be 15. Okay, because that is the operation that we are trying to do. Now between this 15 and 4, how many elements that we can have? 15 minus 4 is basically 11 plus 1. In total 12 elements we will be having, considering the ranges. Okay, why I have done plus 1? Like you just count how many elements that are there, like 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. In total, if I want to know like how many elements that are there, 15 minus 4 plus 1 is something what I have to do. So in total 12 elements will be there, like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 elements that are there, right? So yes, I guess it is taking time again to update, but yes, in total 12 elements are there. So that is something like upper bound minus lower bound plus 1 into I, the current index, because that many operations it requires. Okay, because this index basically refers like how many operations these particular numbers basically requires. Okay, so currently when I was basically equals to 2, so we basically checked between 16 and 4. Between 16 and 4, how many elements basically that are there, like between 16 means like 15 and 4, all the elements that we picked. So in case of here it is not 5, let us suppose if it was 7. Okay, if it was 7, so obviously this lower bound is going to be 7. From 7 it is not, we are not considering 4 at this point in time. So lower bound we got updated with 4. So from 7 to 15, how many elements are there? So 7 minus 15 minus 7 is going to be obviously 8. Okay, 8 plus 1 is going to be 9. So in total 9 elements will be there. Okay, that is how we can figure out. Okay, 8 plus 1 is 9. So in total 9 elements that are there who basically takes two operations. Okay, whatever the current index I value that we have, that is something what we will keep on multiplying. So we got to know like these many total operations we require from 7 to 15. Now going ahead, we will check between this 16 to 64. Are there any elements lying in this range? Again, same operation we will perform. So here the lower bound got updated with 16. Okay, lower bound basically got updated with 16 because same operation we are trying to perform. 7 and between 7 and this array of I minus 1, the array of I minus 1 at this point in time when I becomes 3 is going to be 16. Okay, between 16 to whatever the upper bound that we have, 17 and 64 minus 1. Okay, 17 and 64 minus 1, this particular operation. Okay, so now here the upper bound is basically going to be 17. Okay, so now between 16 to 17 only two elements that are there. Okay, 17 minus 16 plus 1, two elements we got it, like 16 and 17 are the two elements that we have right over here. So these two elements basically take three operations, correct? So we will simply sum them up and we'll multiply them. Going ahead, this conditions does not make any sense, so we can simply avoid them, or we can keep on continuing because they are only taking 15 operations, right? So yes, it is fine, completely fine to go further and we'll keep on calculating them. But the answer so far we got is like from previous one, whatever in total like there were 9 which basically take two operations, and here it is like two elements that are there who basically take three operations. So when we add them, the answer that we are getting is something what the operations we were looking at for. Okay, previously. So here it is like 18 plus 6 is basically 24. So in total 24 operations we have. Okay, so the idea was like we will simply divide them with 2. So 12 operations are something what we require. So that is the whole idea, right? So 12 operations we require here. So if this sum is something what we got it as odd, so we will simply add 1 plus into it. Or even if this sum, whatever the sum that we are getting it, right? Even if even sum is there, like 24 is there, right? If I add 1, the answer is going to be 12 at this point. But when this element is 25, okay, if the element is actually odd, okay, in that case only when we add 1 into it, the answer gets changed into 13. Okay, so 25 plus 1 divided by 2, if I do that, okay, here the answer is going to be 13. Okay, so we will keep on at the end whatever the answer that we are getting it plus 1 we will do it and we will divide it with 2. So if even is there, the answer is going to be the same. If odd is there, the answer correct answer is something we can easily get it. Okay, this way we can solve this one. Let me try to write down the code as well now. Okay, so let me write down the code. The first thing is like we will pre-compute the range, I would say. Let's suppose range, and I already said that this range is going to be all the way to 15 elements. We'll be having this particular one based on the constraint that we have. Okay, and what we were trying to store inside here, we'll run a for loop for int I equals to 0, I less than this. I'll start with 1. at 0th index, range of 0 will store 1, and it goes all the way to 16 I plus plus. So range of I is basically range of I minus 1 into 4. Okay, whatever the previous value that we have, we are simply multiplying it with 4, and that way we will keep on getting the ranges. Okay, now the moment we got the ranges, the idea is we will run through queries. So first is like, let me create here long answer. Initially the answer is basically equals to 0. Let's get queries one by one. So int q, the first query is what I get it. Okay, so yes, here the lower bound LB is basically q of 0. The upper bound is basically q of 1. The moment we got this lower bound and upper bound for this particular query, we will run a for loop, and it will start from I equals to 0. It is going to be I equals to 1, and it goes away all the way to 16 I plus plus. And in this particular for loop, what I can do is we will calculate the ranges. Okay, the first thing is like the lower bound range. Okay, so it should be long because values may get bounce out of the range. So long lower range, LR is what I'll name it. So lower range is going to be whatever this math dot min sorry max between this lower bound value that we have and this whatever the range array that we created, right? uh, its previous index, whatever the current index minus 1. Okay, the previous index, between them whatever the value that we are getting, maximum value, that is something what we will consider for this lower range. And for upper range, I would say map dot min between this whatever the upper bound that we have, this q1. Okay, minimum between this q1 and range of this current I. Okay, whatever the current index we are at, minus 1, because that way we can get correct range. Okay, so if we do not do minus 1 here, we may can further modify the code, but this is fine. Okay, that way we will get clarity like between 4 to 15 how many elements that are there. Okay, if lower bound is 7, so obviously between 4 and 7 is the answer that we can get it, and upper bound is going to be 15. Minimum value is something what we are considering, right? So yes, now that we get this value, so we just have to check that if lower bound is actually less than this upper bound range. Okay, upper range. So I have to define here sum long sum equals 0. So in this sum, we will keep on adding these operations. Okay, so upper range minus lower range plus 1. Okay, that way we will get to know like how many elements that are there into this current index I. Okay, so these many operations, basically these elements that are available in this particular range, they basically requires these many operations. Now we are keep on adding them into this sum. The moment we are done with this, what we can do is in this particular answer, because different queries may get different results, those results is something what we have to keep on adding it up, right? So in this particular answer, what we can do is, I already said that sum plus 1 divided by 2 is something what we can do it. So for odd, obviously correct answer is something what it will be written. For even also, if we add 1, it is going to be same answer. Okay, so it doesn't matter whatever the sum that we are getting it. If it is odd, obviously plus 1 is something what we have to do. If it is even if we add plus 1, right, the answer is going to be the same one. Okay, this way we can do it. Okay, now ultimately we have to return the answer, and now let's try to see if it is working fine or not. Now talking about the complexities, right, like let's see if it is working fine or not. Okay, there is a problem here, it should be long. And let's see if it is working fine or not. Again, it is getting accepted. Let me try to submit the code. So if we see here carefully, the space we are trying to use is only 16 elements we are storing it, right? So the space is constant. Big of 1 is something what we can say that. And the first is like we are running these queries. So in total there are 10 to the power of 5 queries we can have at max. So yes, if there are n queries, n into this for loop we are running all the time 16. So 16 into n is going to be n. Okay, so the time complexity is going to be big O of n. Okay, so that is all about this particular problem. I hope you get the idea. If so, please make sure to like this video. Thank you for watching this one. Bye bye.